All right, CSA people, here's a quick run through of the review worksheet we had from class on iteration unit 4. There'll be a Google form tomorrow with the over this topics. So a couple things, some of them I won't go over because they're pretty straightforward, like this one. You had to put the while loop while x is less than 5. You can have other answers too that still work, and print up 10 in the end. This one, not too hard either. They set num at 3, and it goes through the loop twice. And the first time it resets num to, if you know what math.pow does, it squares it and then squares it again. So just a for loop that runs through twice. Number 3, you got to watch a little better, a little more carefully. So here's the sneaky part of number 3. I'm going to kind of write this one out for you. Okay, so for this one, number 3, a couple weird things. I know I said it in class, but it doesn't say it. But if there's no braces, then the only thing that for loop applies to is what's indented, the very next line. It doesn't even have to be indented, really. It's just the very next line. And then the next thing is outside of that for loop, but it's inside the bigger for loop. So really on this, it's important that you just trace it. Like when I started on this, I said, okay, my outer loop, I is going to equal 0. It's actually important to keep track of that because on your inner loop, the next thing it sees, it sets j equal to I. So right away, I is 0, j is 0. And then it prints out I plus j minus 3. So 0 plus 0 minus 3, negative 3. Now the second time through, it doesn't go back up here, so I is still 0. And now j is going to be worth 1. So now j is worth 1. Okay, we can scribble out the 0 and make it a 1. So now it goes through and says, okay, we're going to do 0 plus 1 minus 3. So 1 minus 3 is negative 2. And these are prints, they're not print lines, so it's just slamming them next to each other. And then it goes through and j is now 2. And 0 plus 2 minus 3 is negative 1, and then j is going to be 3, and then j is 4. And that's the last one j does, right? So 4 minus 3 is 1. And then it goes through again, and you might think, it's going to follow a similar pattern. But now I is worth 1, because it's done all these. It gets a new line printed, so now my next stuff is going to go in the next line. And it goes up here, now I is 1. And j doesn't get to set to 0 this time, j gets set to 1. So our first time through this loop, it's 1 plus 1 minus 3, which is negative 1, right? Because 2 minus 3 is negative 1. And then it goes back up, now j is worth 2. 1 plus 2 minus 3 is 0. Now j is worth 3 the next time through. And 3 plus 1 is 4, minus 3 is 1. And then finally it's 4, because I have to do less than 5. And that's going to be a 2. And then it does a new line. So you can start to see the pattern. It's jumping, this one had 5 entries, this one has 4 entries, and the next one you're going to do the same thing on. I starts out at 2, j starts out at 2. So we're going to have less j's every time. So yeah, if you go back to the answers, you can see kind of where that came from. Each time it gets a new line printed after it's done doing that. And they all put next to each other. Okay, so similarly, we can take a quick look at number 4. Okay, so for this one, it says what will be returned by mystery 5. Okay, so on this one, it's basically telling you that x is worth 5 right away. So that kind of changes this problem to be right here, I is less than or equal to 5, and it starts out at 1 and z starts at 1. So z is set to 1, then you jump in the for loop. Now z is 1, I equals 1. Okay, so I'm keeping track of stuff off to the side. You got to write stuff down for these. And the first time through, and it's going to do this for loop 5 times. Okay, so the first time through, z is reset. So now that I is 1, z is reset to be times I. So old z, 1, times I, which is 1. so z is still currently 1. Now I'm looping back up, and now I is worth 2. Okay, so when I is worth 2, now my old z equals, or my new z equals my old z, which was 1, times the new I, which is 2. 1 times 2 is 2. So then we keep going, it loops back up. I is 3 now. Okay, z, new z, is going to equal old z, which was 2, times 3. So I got 6. And you keep doing this. Now I have my new z is my old z 6 times 4, which is 24. And my last time through, because it's or equal to, I'm going to take my old z of 24 times my new I of 5 and get 120. Okay, so that's kind of how that one breaks down. All right, kind of the same deal here. It starts with an F the first time because it's a small substring. Actually, the first time through it doesn't print anything because J is 0. So if you do a substring from 0 to 0, it doesn't even do anything. The second time through, it's 0 to 1, which just prints your first letter, F for farmhouse. So there's F, and then FA, and then FAR, and then FARM. And after that, it kicks you out of the loop. Okay, so let's keep on going. Semicolon causes the error right here. So that problem didn't really need to be done. Let's take a quick look at 7 and then the code. All right, so looking at this one, we have a code. It's kind of cool. I like it. It's different than usual. One, they tell you what happened. How many times will this loop run if you have a 12 here for your max? Okay, so basically what that allows you to do is put a 12 down here for max. And you know, just like usual, you want to write everything down. So what's weird about this is you're adding 1 to I every time in this while loop, but your while loop is dependent on sum, which is sort of dependent on I. It's just kind of cool. Another thing I don't do very often, but I like it, and I might start doing it more, is if you want to declare more than one integer at once, you can do it on the same line. You can say int sum is 0 and I is 1. All right, so the first time through, sum is worth 0, I is worth 1. That's the first time in. Okay, this question asks how many times does the loop run, or how many times does it run through the loop. So it gains entry into the loop because 0 is less than or equal to 12. Now this is my first time in. Okay, so this is time number 1. I gained entry. Okay, now I'm going to make sum reset to be old sum plus 1. So my new sum is 1. And now I is going to be 2 because I plus plus. Now it goes back up here and it checks, is sum still less than or equal to 12? Yep, so I enter a loop for the second time. Now my new sum is my old sum plus I. Well, I is now 2 and my old sum was 1, so now I have 3. And I is now add 1 to it. So I'm just keeping track of it. Sum is 3. Do I get to enter again? Sure do. Now my new sum will be reset to old sum of 3 plus my new I of 3, so that makes 6. My new I is reset to be 4. Do I get back in my loop again? Heck yeah, you do. And now my new sum is old sum plus I. I is currently 4 because it's resetting it afterwards. So now I have a sum of 10. Reset my I to be 5. Do I get in again? Yeah, that's still less than 12. So it will run for a 5th time. And on this 5th time, sum will become 15. I will become 6, and it never gets back in there again. So I'm tracing how many times it went through. It went through 5 times. All right, so here is my version of the guessing game. There's a bunch of different ways to do this. I just copy pasted this stuff into REPL IT and kind of filled it in as I went. So the scanner thing has to be your first line. I really erased everything and copy pasted it. Choosing a random number from 0 to 100, I made a new rando num, and make sure you go times 101. If you only went to 100, you're missing the possibility of the last digit, because remember, it truncates it. So this produces a number between 0 and 100.999, but when you integerize it, when you cast it as an integer, you chop off that and make it 0 to 100. Now I did this just so it looks better, and I said I'm thinking of a number between 1 and 10, guess what it is, and then you store the first guess. It needs this first guess stored before you get into your loop, because you want to make the loop work while the guess does not equal the random number. Here's not equals, rando num from up here. It produces that first before it gets down here. And then you want to have a case if you're less than the number, say it's too low. I wanted to be more specific because when I played it, it was kind of hard. Oops. It was kind of hard to see what I guessed. Now it says 50 is too low, guess again. So I'm like 75. 75 is too low, guess again. 87. 87 is too high, so it's between 75 and 87. This helped me in the printout of the game. You didn't have to do this, but I think it made it easier to follow. 82 is too low. How about 85? Too low. 86. I liked when it told me what it was. So yeah, you got an if for too low, an if for too high, and after it kicks it out, oh, by the way, your guess has to be outside of these if statements. I guess you could put the guess inside each one of those if you wanted. No, that's a bad idea, because then it would, yeah, if you put it in here, it would look down here next. So that's not a good idea. You want to definitely have the guess outside of your ifs, but inside of your while loop. And then the got it, my number was 86. Okay, so that's a breakdown of that one. Okay, so this cat dog replacement thing here, basically you can't change the name and REPL of the class. It's just called main. So just copy paste the main part and put it in there. And the first important thing to do when you write a loop that replaces every occurrence of cat, you can make a while loop that just notices if the word cat is still in the text. So if I took message, which is set up above, and you can change the message just to see. If I have message.index of cat greater than or equal to 0, it means the word cat is somewhere in your message. So basically, just knowing that index of returns a -1, if it's not, is a good thing. Now I'm going to write the line of code here to replace cat with dog. Alright, so this next line is pretty tricky. You're basically going to reset this original message to be pieced up. You're going to piece it together. You're going to have the message substring from 0 to wherever cat occurs. So just at the beginning of cat, remember it doesn't, substrings don't include the end point. It includes the beginning point, but not at the end. So it finds where cat is. It goes up until that point. Then you concatenate that with the word dog, and then you want everything after the word cat. So basically it would be I love, and stop right there. Replace these 3 letters with dog, and then try to grab it from here and go on out. So basically that's what here is the replacing with dog, and here is the rest of it, which is just the index of cat and add 3. Oh no. Oh no. Okay. Okay, and then it'll run again and it'll replace that first cat. Remember, index of finds the first instance of it, so it finds that cat. The second time through, it'll find that cat. The third time through, it'll find that cat. I'm going to pause it and finish the code. Okay, so the last part is make a replacement tracking variable. So I went up top where I declared it and set it equal to 0. You don't want to set it equal to 0 in here. So you got to do it before your while loop, and then every time it gets into the while loop, which means every time it finds a cat and replaces it, you keep track of it just by adding 1. And down here, in addition to printing the message, I also said cat was replaced blank times. So if you run it, you'll see it replaces it. Hopefully, there it goes. I love dogs. I have a dog named Coco. My dog's very smart. Cat was replaced with dog 3 times. You can change this up top, try out a few different ones. Hope that helps. Talk to you later, people.